Hey guys, feel like making another quick video here. It's on a new paper in addition to the volume principle of life formation and stellar metamorphosis, plus last universal common ancestor, also known as LUCA or LUCA. It's a biological term. Some calculations are done to hypothesize what the minimum volume of the stars needed to begin the formation of life. This paper builds on the previous volume principle of life formation. To form life, vast volumes of material is needed to increase the statistical likelihood of molecules mixing in ways that resemble complex proteins, sugars, and long-chain hydrocarbons which branch, such as phospholipids. This, of course, is far before any feedback and self-regulating mechanisms spring up. This is just to address the simple act of mixing elements and recombining them in large scales. There is to date no other theory that connects young stars directly to the formation of life. This paper's goal is to help alleviate this vacuum and places reasoning to the last universal common ancestor issue raised by academics and researchers. Okay. Two main things here. Well, there's a lot actually here, but two main things. Number one, in order to form life, you need a lot of material to mix together. So randomness can play a part and forming molecules that are biological in nature. Before life even forms, before there are natural feedback loops that exist in cells in simple life like prokaryotes and eukaryotes, algae, viruses, and even down to the cell's organelles such as ribosomes, lysosomes, Golgi apparatus, mitochondria, the nucleus of the atom, including the DNA. Before you even get to that, you have to have some ability to take I'm sorry, I'm going to cuss right now. This is the best way to explain it. A fuck ton of material and mix it all together to at least get the very basic amino acids formed. Because you can't form a feedback loop without the material that's doing the feedback even existing before you have the feedback loop. I mean, you have to have the gasoline in the gas tank before you can inject it into the cylinders of the car and then you spark the cylinder to get it to run. The gasoline had to exist before any of this can even happen. And those are long chain hydrocarbons, similar to phospholipid bilayers of cell walls, where you have the three long hydrocarbon chains and you have your phosphate group at the head. And you've seen these in biology class where you take the two phospholipid heads, and I think they form the outer regions. And I think it's the tails that form the inner regions, or I might have that backwards. I'm not too sure. But basically, that's what forms the cell wall. But if you'll notice, those are hydrocarbons, mostly. The same stuff diesel fuel is composed of. Gasoline, it's octane, nonane, decane, all that stuff. And you need a lot of material to make those hydrocarbons exist before life even occurs. That's why I sincerely believe that oil, natural gas, those are abiogenic. You don't need the majority of those materials, the majority of hydrocarbons formed during stellar evolution, long before life even came to be. So in essence, this paper, and I have the volume set arbitrarily at 2 times 10 to the 15 cubic kilometers of material, because that is about where red dwarf stages are, and that is the stage at which the star is cool enough to where the strongest material or the strongest bonds can form first, and then as the star cools, then bonds that aren't as strong will begin forming too. So basically, if you want to look at the formation of life, and I don't have this in the paper, you want to start with the organic material that would have had the strongest chemical bonds. Those are the bonds that form first. And then you have the weaker and weaker and weaker bonds as the star cools down, and they can't be broken up by the energy of the star ripping them apart. I guess I should put that in here. As well, I have red dwarfs as the minimum, as the minimum amount of volume, because life is directly involving young hot stars. The stars in the galaxy are what form the life, meaning the evolutionary processes that we see on the Earth are a direct and intimate result of the Earth's evolution. It isn't that life came from outer space and then it was planted here. No, the Earth made all the life that's on it. And the environment is what steered it to evolve in specific fashions. So when we look at the stars in the night sky, I think astronomers should look at the stars like this. The stars, astronomer and biology type people who mix their two fields together, they should look at the stars as being their own LUCAs, or the last common universal ancestor. Because as the star evolves, take any random red dwarf, any brown dwarf, that star will create all of its own life as an independent system of any other star. Which means all the life on that star is related directly to that star and is made directly of that star's material. So, in essence, Earth is our last universal common ancestor. The Earth made us, and we are going right back into the Earth when we die. Unless you're really rich and you can blast yourself back into outer space to orbit the sun or something really expensive like that when you die. Be a spaceman, a space corpse. But anyways, and also it would be helpful to look at life as being look at biology too. Look at the cell. I remember I learned this in my biology class. When a cell increases in size, the volume per unit volume gets greater than the surface area does, meaning its metabolism rates go slower because it has a lot more processes to accomplish, given the size increases volume wise versus surface area, because volume increases by the cubic and surface area increases by the square. So say for instance, this is just a quick example. I put this in the paper just as a little relation type thing. If you have a sphere of a radius of around 7 feet, we'll say feet or meters, 7 meters, the volume is going to be about 1,437 meters, cubic meters of air of space, internal space inside that sphere. But if you half that, we'll say not even half that, if you have the radius of the sphere as being 4, then the volume is 268. So about 1/7 or 1/6 of the volume, but you didn't even half the radius of that sphere. Meaning, when you increase the volume of something, you can do a whole hell of a lot more moving and shaking and mixing than you can on something like Earth, where all the life is just on the surface, on a very thin little sheath, encapsulated by a thin atmosphere and a relatively thin ocean, which isn't even that voluminous itself. It's like the volume of Earth's total oceans and of the atmosphere too is 5.35 times 10 to the 9 kilometers cubed. So I have the base for red dwarfs as being 2 times 10 to the 15 cubic kilometers. So about six magnitudes of more volume is needed to create life and to mix the molecules in ways randomly before there are any feedback mechanisms to form the simple compounds that life will then start building on top of. Um, and it doesn't need to be as big as Jupiter, or as big as the sun. As well as the sun is just too hot, it'll break up any type of strongly bonded material. We need to go with chemistry, and that the really important stuff happens when the star is cool enough to form the strongest bonds. And I already mentioned that. But keep that in mind. When you have something where it's extremely voluminous, you can do a lot more stuff with it. And the attitude of astronomers and geologists and biologists is that life formed on the Earth with the Earth's current size as it is now. But using this theory, we learn that in order to form life in its current state, you can't assume life formed and began from its earliest stages on something like the Earth as it is now, even if the Earth was really hot. You had to have had an incredible amount of volume to mix molecules in a way randomly with enough time involved as well. That's another time principle. With enough volume, that way, the very basis can start out. You can get it kick-started. Without that, you have no life. And this is also direct evidence. The life that exists on the Earth is direct evidence that the Earth simply had to be at least the size of a red dwarf. There's no other way for the complex organic material that's formed on the Earth to even exist if that wasn't true. And that's something that the astronomers are going to definitely struggle with. But anyways, take it easy, you guys.